Now let's say this is the graph of a function f, y equals f of x, and you want to find the slope of this function at x equals c. You want to find the slope of the tangent line to the function or the slope of the function. You can interpret it either way. At x equals c. How can we find the slope of this line? Well, how you can think about it, we can find the slope of a tangent line. We can find the slope of this tangent line. We can find the slope of this tangent line. We can find the slope of this tangent line. And we can take the limit of the slope of secant line. I meant secant line. I'm sorry for the tangent lines. We are going to take the limit of the secant lines as the points are getting closer and closer to x equals c, the point cf of c, and we're going to see what those slopes approach as the points are getting closer and closer to c. Now, how can we do that mathematically? Well, how we can do it, we can think of this point as having x coordinate of c plus delta x. Delta x is how much we have moved away from c. Now, what's going to be the y coordinate of this point? Well, y coordinate, x coordinate is c plus delta x. Y coordinate is the thing you get when you plug c plus delta x into f of x. So y coordinate is going to be f of c plus delta x. Now, what's going to be the slope of the secant line? What's going to be the slope of this secant line? Well, slope of the secant line is going to be delta y, change in y, over delta x. How much have we changed in y? Well, this distance is going to be f of c plus delta x, and this distance is going to be f of c. So how much we have changed, which is this distance, delta y, is going to be f of c plus delta x minus f of c. F of c plus delta x is this, f of c is this. So when you subtract f of c from f of c plus delta x, you're going to get this, which is the change in y. And the change in x is going to stay the same because change in x in this case is delta x change in x. So how can we, well, that's the slope of the secant line. So how can we find the slope of the tangent line at x equals c? Well, we can do that by making this delta x approach 0. If this delta x is 1/2, the point is going to be 1/2 away from c. If this delta x is 1/4, it's going to be 1/4 of the way away from c. If this delta x is 0.00001, this point is going to be very close to x equals c, and you are going to get a better and better approximation of the slope of tangent line. So what you can do to find the slope of tangent line, we are going to take limit as delta x is approaching 0 of our slope of secant line, or limit as delta x approaches 0 of f of c plus delta x minus f of c over delta x. Now this thing, one of the most important concept in calculus, is called derivative. It's a derivative of function f at x equals c. You can also think about this as being the slope of the graph at x equals c. You can also think about this as being the slope of the tangent line to the graph at x equals c. And in later videos, we're going to look at how we can evaluate this without doing the limit process. We're going to memorize and learn the rules which we can apply to make this process, taking this limit easier.